Welcome to Factory on Air by DBR77, where smart manufacturing gets real. This is episode 13, Communicating Machine Failures to Maintenance Teams. Delayed or unclear failure reports waste time, resources, and nerves. In this episode, we dive into how structured data, automatic alerts, and smart diagnostics can drastically cut downtime and boost team efficiency. You'll hear how companies are using DBR77 to collect real-time machine data, auto-generate failure reports, and detect root causes before a technician even arrives on site. From IoT sensors to AI-driven insights, we'll show you how communication becomes your strongest maintenance tool. Factory on Air is powered by DBR77, the platform that transforms equipment failure data into fast decisions and better uptime. Let's get started.
Welcome, deeply curious industrial professionals, to the deep dive. I know your world, the rhythmic hum of production lines, that constant drive for peak efficiency, and that unwavering pressure for maximum uptime. Today, we're not just scratching the surface, we're taking a real plunge into a challenge that's absolutely critical, yet often surprisingly overlooked. It's a kind of silent saboteur that can quietly but profoundly erode your operational stability. Poor communication and maintenance, specifically when it comes to truly understanding the causes of machine failures. Our mission in this deep dive is to give you, a shortcut, a way to get exceptionally well informed on this vital topic, turning what might be a vague problem into clear, actionable insights for your plant.
And we absolutely understand the stakes for you. Whether you're on the factory floor, managing logistics centers, maybe making strategic decisions, this isn't just about minor annoyances or, isolated incidents. A breakdown in communication about failure directly impacts your entire business ecosystem. We're talking about significantly increased downtime, a wasteful expenditure of valuable technical resources, and spiraling operational costs that can really eat away at your profitability. Our goal today is to move beyond just sort of identifying these problems and instead provide you with concrete insights and truly actionable strategies to elevate your operational excellence, turning those challenges into opportunities for growth.
Exactly. We've taken a crucial analysis on communication for maintenance about failure causes as our core source material, really digging into the intricacies of how information flows, or maybe more often, doesn't flow when something goes wrong. Our mission, as always, is to extract the most important nuggets of knowledge and insights specifically for you, helping you streamline your operations, boost your overall equipment effectiveness, and ultimately enhance your competitive advantage. And along the way, we'll briefly touch upon how some modern digital platforms, leveraging advanced analytics and digital twin technology like DBR77, which is a prime example in this evolving space, are purpose-built to address these very issues in a practical and impactful way, showing you what's possible today.
Fundamentally, this deep dive isn't just about the reactive process of fixing things faster, though that's certainly a valuable outcome, right? It's about achieving a profound understanding of why things break in the first place, moving you from merely patching symptoms to addressing root causes. This deeper insight enables you to prevent recurrence, thereby consistently improving key performance indicators like overall equipment effectiveness, or OEE, and securing a lasting, defensible competitive edge in your market. It's about moving from firefighting to foresight.
So let's unpack this. We're going to start by looking at the silent saboteur, the high cost of poor communication in industrial maintenance. And I want to pose this to you, the listener. What really happens when vital information about machine failures isn't clear, isn't precise, or isn't timely? Because it's far more than just a minor inconvenience, isn't it? It creates a ripple effect, a cascade of negative consequences that can sweep across your entire operation, impacting everything from the shop floor to your supply chain.
It absolutely does. And the first major consequence, one that hits hard and immediately, is delayed repairs. Imagine a critical piece of equipment goes down on a busy line. The initial report coming in is vague, perhaps just a hurried verbal description like, number 3 press is jammed, not moving. Or worse, maybe an illegible handwritten note on a greasy production sheet. Noise, then stopped. Your maintenance team receives this before they can even begin to formulate a solution, before they can dispatch the right specialized resources. They lose precious time. They're not fixing, they're deciphering, they're making calls, chasing down the operator who saw it happen, trying to get more context. This isn't just about the time the actual repair takes, you see. It's the critical delay in initiating the repair process that can compound exponentially. Those initial minutes, those hours spent just trying to understand the problem, are pure, unrecoverable loss.
That's a powerful point. So the implication there is stark. Without clear, immediate information, maintenance teams are essentially flying blind. They're reduced to reacting to symptoms, chasing ghosts, rather than genuinely understanding the underlying issues. It sounds like a very inefficient way to operate, forcing them into a constant state of reactive firefighting, always behind the curve.
Precisely. And this lack of fundamental understanding, this constant state of chasing symptoms, brings us directly to our next major problem: recurring problems. When the true root cause of a failure isn't properly documented, isn't thoroughly analyzed, or isn't clearly communicated across the team, perhaps because the initial diagnosis was rushed or incomplete, that same malfunction is highly, highly likely to reoccur. Think of it like this. It's kind of like putting a bandage on a wound without first cleaning it out. Sure, the bandage might offer a temporary superficial fix, it might stop the immediate bleeding, but the core issue, the underlying infection, and the potential for re-injury, they persist. You're patching the symptom, not curing the disease, and that machine will break down again, often at the least convenient moment.
And when you're repeatedly patching the same problem, when you're caught in this cycle of recurring breakdowns, it must have significant economic implications, right? Beyond just the immediate cost of the initial repair, there's a multiplicative effect on resources that I imagine goes well beyond the surface.
Absolutely. The economic implications are substantial, leading directly to wasted technical resources. Consider your highly skilled maintenance technicians. They are invaluable assets, trained in complex diagnostics and precise repairs. But if the initial information about a failure is flawed or incomplete, they might spend valuable time on incorrect diagnoses, essentially. Well, glorified guesswork. This leads to ordering the wrong spare parts, costly inventory sitting unused, or worse, a rush order for the correct part at a premium, incurring expedite fees and stressing supply chains. They might perform unnecessary service actions or even inadvertently introduce new issues while probing in the wrong area, all because the foundational information was faulty. This translates into skilled personnel being inefficiently deployed on elementary detective work, directly costing your company money in labor hours, in material procurement, and further extending the already costly downtime. It's an opportunity cost, too. That technician could have been working on preventative maintenance or optimizing another critical machine.
So it's not just about the machines. It's about the people, too. I can truly imagine the human impact within the plant, facing these kinds of persistent, unclear, and recurring problems. The frustration must be immense.
Indeed, it inevitably fosters significant frustration among the maintenance team and operators. Operators are often the first line of defense. They see and hear the subtle cues, the early warnings, long before a catastrophic failure. If their observations, which are often invaluable insights gleaned from daily interaction with the machinery, aren't properly captured, valued, or acted upon, they feel unheard and disengaged. They might even stop reporting details, thinking, what's the point? Simultaneously, technicians feel perpetually overwhelmed by this reactive firefighting, constantly trying to put out blazes without adequate tools, clear instructions, or the right information to do their job effectively. This environment creates a pervasive sense of blame, a loss of morale, and a significant demotivation across the entire workforce. It erodes trust and teamwork.
And if we zoom out, taking in all these compounding issues, delayed repairs, recurring problems, wasted resources, and the widespread team frustration, what's the overarching business impact on the entire manufacturing floor? What does this silent saboteur ultimately do to the bottom line?
The cumulative effect is a direct and very significant increase in overall maintenance costs and a tangible decrease in machine availability. These are not abstract concepts, but direct, measurable hits to your bottom line. Increased maintenance costs erode profitability, often unpredictably, making budgeting a nightmare. And reduced machine availability means you can't meet production schedules, which impacts customer delivery timelines, and ultimately severely damages your company's competitive position in the market. It can be the difference between fulfilling orders on time, maintaining customer trust, and losing contracts to more reliable competitors. This silent saboteur, poor communication about failure causes, can truly undermine the stability and profitability of an entire enterprise, making it less agile and less responsive to market demands.
That's a powerful and frankly a bit alarming picture you've painted. But if this pervasive lack of precise information and data is such a formidable problem, how then does the systematic collection of information directly address and transform these very challenges? How do we turn that around from a weakness into a strength?
It's a fundamental paradigm shift, truly, a move from chaos to control. Systematic data collection, and by that I mean capturing precise details about the exact time a failure occurred, its specific location on the machine or line, and the precise quantifiable characteristics of the malfunction dramatically shortens the diagnosis time. You move away from subjective or vague descriptions like it made a funny noise or it just stopped to objective, verifiable data points. Vibration spike at X hertz at 14.32.05 on bearing A of motor 3. This is the difference between blindly searching for a problem, often based on a technician's memory or a hurried conversation, to having a clear, data-driven, evidence-based diagnosis. It gives your teams a crystal clear starting point for every intervention, cutting down that initial what's actually happening phase from hours to minutes.
So it's about giving your maintenance teams a crystal clear data-backed starting point for every intervention, cutting down that initial what's actually happening phase. That's an immediate win.
Exactly, and the power doesn't stop there. By meticulously analyzing the history of failures for a specific device or machine type, incredibly valuable patterns and correlations begin to emerge that might otherwise remain hidden or appear as isolated incidents. You can start asking crucial data-backed questions. Does this particular machine consistently fail after a certain number of operating hours? Or does a specific type of malfunction reliably occur following a particular product changeover, or perhaps after a certain material is run through it? These patterns are crucial indicators of probable root causes that, without systematic data, might be dismissed as random, unrelated events. But with the data, they start to tell a coherent story, highlighting the true underlying vulnerabilities.
That's fascinating. It sounds like this isn't just about mere reaction anymore. We're moving towards prediction, towards foresight, allowing us to anticipate problems before they become critical.
Absolutely. It's a definitive shift to proactive strategies through the analysis of failure trends. Let's use a concrete example from, say, a plastics manufacturer. If a facility reputedly observes the same type of errors or faults, say, a specific mold clamping mechanism failing immediately after a particular machine changeover or when processing a new polymer, that's not just a random fault. It's a strong signal that the changeover procedure itself may need optimization, or that a particular component is under undue stress during that specific process. This insight enables preventive actions to be taken before the next costly failure occurs. You're not waiting for it to break again. You're stepping in to prevent it, perhaps by retraining operators on changeover procedures or by scheduling more frequent inspections of that particular clamping mechanism during those critical periods.
And how do real-time insights play into this data revolution? Where does that fit in, especially with the modern industrial landscape increasingly embracing connected technologies?
Real-time insights are absolutely critical, and they come primarily from the integration with IoT sensor systems. Imagine a concrete scenario. Your system detects a sudden spike in temperature or an unusual vibration signature, or an abrupt drop in motor current just moments before an engine failure. Without sensor data, the report would simply be, the engine broke. But with IoT data, you have a crucial, immediate piece of context that often points directly to why it broke, or at the very least, provides a critical lead for immediate investigation. This real-time data allows for far more precise and rapid diagnoses, often even allowing for interventions before a complete breakdown occurs. It's the difference between a forensic autopsy and, well, a live diagnostic scan.
It sounds like manual reporting systems would struggle immensely to keep pace with these demands, let alone provide the depth of insight we're talking about. What is the specific role, and what are the benefits of automated reports in modern industrial maintenance?
You're absolutely right. Manual systems are inherently slow, error-prone, inconsistent, and ultimately a bottleneck in a fast-paced production environment. That's why automated reports are absolutely crucial for standardizing and accelerating the flow of critical information. After every single failure event, a report is generated automatically, virtually eliminating human error, subjectivity, and the inherent delays found in any manual process. The machine reports on itself, or the system reports on the machine, immediately in a structured format without waiting for an operator to manually fill out a form or send an email.
So what kind of precise information do these automated reports encapsulate? What can we expect to see in them beyond just machine stopped?
They capture a wealth of critical, granular data points. This includes the precise time of the stoppage, clear identification of the machine and the specific production line or cell involved, and often even the operator who was active at that moment. Crucially, they contain a comprehensive record of data from all relevant sensors leading up to and during the event. This might include second-by-second temperature readings, pressure levels, vibration patterns, current consumption, lubricant levels, and more, all time-stamped for context. Furthermore, these reports often include a proposed classification of the cause. For example, electrical, mechanical, human error, material defect, or software issue. This classification can be based on predefined rules or, in more advanced systems, an initial AI analysis, giving a significant head start to the diagnostic process by narrowing down possibilities.
That's incredibly valuable, an immediate, comprehensive snapshot that practically guides the maintenance team, almost diagnosing itself before a human even lays eyes on it.
And it's not just about creation. It's about efficient distribution and systematic archiving. These reports can be sent directly and instantaneously to the relevant maintenance team members, whether that's a specific technician, a supervisor, an entire shift, or even a third-party service provider, eliminating any waiting for manual forwarding or chasing emails. Furthermore, they are archived systematically in a computerized maintenance management system, or CMMS, or an equivalent digital platform. This systematic archiving is absolutely essential for building that vital, long-term historical database, enabling the powerful trend analysis capability we discussed earlier. It becomes a living record, a library of machine behavior, failure modes, and their contexts, which only grows more intelligent over time.
The difference from traditional, often paper-based methods must be transformative for operational teams.
It truly is. This system eliminates the dependence on unreliable manual reporting, no more guessing what was written, struggling to decipher handwriting, or hunting for a misplaced paper report. And it minimizes information delayers by orders of magnitude, ensuring that the right people possess the right information at the exact moment they need it most. It transforms what was often a chaotic, fragmented, and delayed communication process into a streamlined, efficient, and data-rich workflow. It moves you from reacting hours later, often with incomplete information, to acting within minutes, equipped with precise data and a clear direction. This speed and accuracy can fundamentally redefine your maintenance strategy.
These theoretical benefits sound compelling, but I know our listeners working in the industrial world appreciate concrete evidence. Let's transition from theory to practice. Can you share some real-world examples that vividly demonstrate the measurable impact of improved communication and data analysis in industrial settings? Give us some stories of success.
Absolutely. The impact is very tangible. These aren't just hypotheticals. Take our first example, an electronic components manufacturer. This company was struggling with intermittent, hard-to-diagnose failures on their automated assembly lines, leading to significant scrap rates and unpredictable downtime. After implementing automatic reporting systems for machine failures, where every stoppage automatically triggered a detailed report, including sensor data and operator input, they experienced a remarkable 35% reduction in their average repair time. This wasn't just about technicians physically moving faster. It was because they arrived on site with a strong understanding of the probable cause, often already equipped with the correct diagnostic tools, and in many cases, the necessary spare parts. They moved from a find the problem mission to a fix the problem mission almost immediately. This meant faster line restarts and a significant boost to production continuity.
Wow, a 35% reduction in average repair time. That's a substantial leap in operational efficiency. That's real money saved and production regained, directly impacting the bottom line and customer delivery promises.
Indeed. And here's a second compelling case from a wood industry plant. They were plagued by a persistent issue. Their high-speed cutting saws would frequently jam or produce uneven cuts, often traced back to improper setup after material changeovers. It was a recurring headache, costing them material and production hours. Through detailed analysis of their systematically collected failure data, which combined sensor readings with specific data about the wood type and machine settings, they were able to identify and completely eliminate a recurring machine setup error that had previously been a persistent, frustrating problem for them. This single data-driven insight, by pinpointing the exact procedural flaw during changeovers, led to saving 200 man-hours annually. Imagine the compounding effect of identifying and proactively addressing such systemic issues not just once, but permanently across an entire manufacturing operation. It's a shift from just fixing problems to actively preventing them at their source, turning a chronic weakness into a consistent strength.
That's a great distinction, moving beyond just fixing problems faster to actually preventing them from happening again. That's truly next level.
For a third example, consider a logistics company with a vast fleet of automated guided vehicles, AGVs, operating in a large distribution center. Downtime on any single AGV could cause ripple effects, slowing the entire picking and sorting process. This company leveraged rapid reporting of transport system failures, often through a mobile application directly from the AGV operators. This immediate structured feedback, including location, error codes, and even photos from their operators, resulted in a 20% reduction in fleet downtime. In dynamic environments where assets are dispersed and constantly moving, mobile technology empowers operators to provide instant structured feedback, which is absolutely crucial for quick incident resolution. An operator reports an issue, the precise location and specific fault code, and the maintenance team is already mobilizing, even if the AGV is still in a remote corner of the warehouse, cutting resolution time dramatically.
These examples vividly illustrate the tangible, measurable benefits from significant time savings and reduced labor costs to overarching improvements in operational efficiency and resource optimization. It's not just about nice-to-haves. These are fundamental business improvements that directly impact competitiveness. Those case studies are incredibly inspiring. They show what's possible when a company commits to better communication and data. Now let's talk about how modern technological platforms are purpose-built to address these complex challenges we've discussed. Our source material introduces DBR77. How does a platform like DBR77 specifically approach the critical task of identifying the root causes of failures, bringing all these data points together?
What's fascinating here is that DBR77 offers a comprehensive ecosystem-based approach, integrating multiple layers of technology. It actively collects real-time data from machines and various sensors across the entire production floor, mirroring those IoT principles we discussed earlier. This continuous stream of data immediately registers every stoppage or operational anomaly on a production line. Think of it as having an always-on digital watchdog for every critical asset, turning every event into a rich, time-stamped data point, ensuring nothing goes unnoticed.
So it's not just collecting data. It's like having an intelligent, vigilant monitor that captures the pulse of your entire operation in real time.
Exactly, but it goes far beyond mere collection. The DBR77 system then analyzes the vast amount of parameters immediately preceding an anomaly or actual failure. This involves scrutinizing subtle shifts in vibrations, minute changes in temperature, pressure fluctuations, or any other critical operational parameter that might indicate an impending problem. Based on these advanced analyses, which heavily leverage artificial intelligence and machine learning algorithms, the system then assigns a probable cause, significantly streamlining the diagnostic process. This is where the power of advanced analytics and AI comes into full effect, transforming raw sensor data into actionable insights, often faster and with greater accuracy than a human could achieve alone, giving maintenance teams a massive head start.
That's a powerful step, assigning a probable cause and giving that initial direction. But as we know, failures rarely occur in isolation. They're often interconnected within a larger system. How does a system like DBR77 help understand the broader context, not just the single point of failure?
This is where digital twin technology within DBR77 becomes incredibly powerful and a true game changer. A digital twin is essentially a virtual and mathematical model of a real production facility or a logistics center, a living, breathing digital replica. This virtual twin can simulate the effects and the entire context of an occurring failure, allowing for deep scenario testing and comprehensive analysis without ever disrupting actual operations. Imagine being able to simulate how a bearing failure on one machine impacts the vibration patterns of an adjacent machine, or how a material flow interruption affects an entire upstream and downstream process. This functionality is absolutely key to gaining a deeper understanding of the why and how behind an incident, including external factors, sequential dependencies, and cascading effects that might not be immediately obvious on the shop floor. It allows for forensic analysis in a risk-free virtual environment.
That represents a significant leap in diagnostic capability, moving beyond just the immediate machine to understanding its place within the entire operational ecosystem. But what about situations where full sensor coverage might not be feasible, perhaps with older legacy machinery, or where human insight and experience remain invaluable? Does the system account for that?
DBR77 takes a very pragmatic, kind of human-centric approach to this as well, recognizing the irreplaceable value of human experience. While it champions sensor-driven data, it also ensures that operators can manually report failures and their perceived causes through user-friendly interfaces, such as mobile apps. Crucially, this manually entered data isn't left unstructured. It is then structured and analyzed by AI, integrating valuable human experience and observation with automated data. This provides a more holistic picture and continually refines the AI's learning over time, creating a feedback loop between human insight and machine intelligence. And for those older machines you mentioned, the DBR77 source material notes that the platform also offers practical hardware solutions, such as dedicated, easy-to-install sensors to address issues of data quality and availability, ensuring even legacy equipment can contribute effectively to the modern data ecosystem. No machine is left behind, essentially.
So it's about empowering human operators with advanced tools and analysis, turning their observations into structured data rather than trying to completely replace them. It creates a powerful synergy between human and artificial intelligence.
Exactly. This integrated, data-driven approach to failure identification makes the entire process faster, more precise, and more comprehensive. It directly reduces those critical minutes and hours of downtime that impact productivity and profitability, effectively turning potential disasters into manageable, quickly resolved incidents. It's about leveraging every piece of available information to your strategic advantage.
Now, let's talk about the ultimate payoff. We've gone through the problems, the data revolution, the technology. What are the concrete, measurable benefits that industrial manufacturers can expect to realize from investing in improved communication and data analysis around failures? What's the real return on investment for all this effort?
The return is incredibly clear, tangible, and impactful across multiple fronts. The most immediate and significant benefit, the one that every plant manager keeps a close eye on, is undeniably shorter machine downtime. Every single minute a machine is stopped represents lost production capacity, lost throughput, and that directly impacts your revenue and your ability to meet customer demand. By significantly accelerating diagnosis and repair times, these solutions directly minimize that critical loss, keeping your production lines moving and your output consistent and predictable. We're talking about potentially saving days of downtime per year, which translates directly into millions for some operations.
And does this also lead to greater efficiency in the repair process itself beyond just shortening the time? Does it mean better quality repairs?
It absolutely does. Manufacturers will observe a smaller number of incorrect repair decisions. When your teams have access to precise data, to robust root cause analysis, and to a clear historical context, technicians are empowered to make informed choices from the very start. They're not guessing, they're operating with certainty. This leads to fewer wasted spare parts because you're ordering the right ones, reduced rework because the fix is right the first time, and ultimately faster, more effective, and more durable problem resolution. You're not just doing things quickly, you're doing them right the first time, every time, reducing the chance of that immediate reoccurrence.
So the benefits extend beyond just the maintenance department to the broader production side of the business, impacting overall operational flow.
Yes, these efficiencies translate directly into smaller production losses and better utilization of all your expensive resources. When machines operate reliably and predictably, production targets are more consistently met, and your expensive capital equipment is actively producing as intended rather than sitting idle. This optimizes your entire operational flow, from raw material input to finished product output, leading to better planning, reduced inventory buffers, and a leaner operation. It's about getting the most out of every asset you own.
And what about benefits that extend beyond just reacting faster to current problems? Does this rich data stream help with future planning and strategic decision-making?
That's a key forward-looking advantage, a pivot from reactive to predictive. This improved data visibility provides the invaluable ability to plan preventive actions with unprecedented accuracy. Instead of waiting for a catastrophic failure to occur, which is always costly and disruptive, patterns can be identified, potential issues predicted, and maintenance can be strategically scheduled during planned shutdowns. This allows for proactive interventions, perhaps replacing a component nearing the end of its predicted life, or recalibrating a system, showing early signs of drift, preventing those unplanned emergencies that halt production and throw schedules into disarray. You're moving from a reactive stance to a truly predictive one, optimizing uptime and resource allocation.
All of this sounds like it culminates in a critical metric for plant management, doesn't it? The one that often dictates success or failure.
It does. All these benefits fundamentally lead to an increase in the technical availability of the entire machine park. This is a paramount metric for any production facility, perhaps the paramount metric. It ensures that your assets are consistently ready to produce when needed, directly impacting your overall equipment effectiveness, or OEE, and consequently the overall plant profitability. When your machines are available, they can be utilized, and when utilized effectively, they generate maximum revenue. It's the engine of your operational success.
While the benefits are incredibly compelling and the technology sounds promising, implementing these data-driven approaches isn't always straightforward in the real world of industrial manufacturing. What are some of the common challenges and obstacles companies encounter when trying to effectively analyze failure data and build these systems?
This is a crucial point because simply wanting better data isn't enough. Implementation comes with significant hurdles. One of the most significant is the low quality of initial failure reports. If your input data is poor, if it lacks precise descriptions, if crucial numerical data is missing, or if inconsistent terminology is used across shifts or teams, then even the most sophisticated analysis system will struggle to generate reliable, actionable insights. It's the classic garbage in, garbage out principle. Your advanced analytics are only as good as the information they receive, and if that foundational layer is weak, the whole structure can wobble. This often stems from a lack of standardized training or poorly designed user interfaces that don't prompt for the right information.
That really emphasizes that the human element remains absolutely critical, even with increasing automation and advanced systems. The initial human observation is key.
Indeed. Another common challenge is the pervasive dispersion of data among different teams and systems. You often find that departments like production, maintenance, and quality control operate with their own isolated data silos. This might be disparate spreadsheets, legacy databases that don't talk to each other, or even unrecorded verbal traditions passed down through shifts. This fragmented information environment makes a holistic, cross-departmental analysis extremely difficult, if not impossible. You simply can't see the whole picture, identify complex interdependencies, or truly understand root causes if the pieces of the puzzle are scattered everywhere and not integrated. This often comes down to organizational silos and a lack of common platforms.
Now, what about the sheer complexity of actually connecting all these diverse data types? It's not just gathering, it's making them speak to each other in a meaningful way.
That's a significant hurdle that often requires specialized expertise. There's often difficulty in seamlessly connecting IoT sensor data with existing operational data. For instance, while sensors might accurately report a temperature reading of a motor, integrating that information to understand its precise relationship to a specific production batch running at that exact time, or the operator shift currently active, or a particular type of raw material being processed, requires careful and often complex integration efforts. It's not just about getting the data, it's about establishing the contextual links and making it speak to other relevant data points to create meaningful, actionable insights. This often involves intricate data mapping and integration projects.
And I imagine a widespread issue in many facilities, particularly in older industrial sectors, is the prevalence of older equipment that wasn't built for a connected world.
Absolutely. We must address the significant point of technical limitations with older machines that often lack built-in sensors or modern data interfaces. You simply cannot collect rich, real-time data if the machine isn't equipped to provide it. This constraint often necessitates strategic planning for sensor retrofits, which can be a capital investment, or innovative ways to integrate legacy equipment into a modern data collection system, perhaps through third-party data acquisition devices that can listen to older machine signals. It's a real barrier for many established manufacturers, but one that can often be overcome with targeted solutions.
Okay, so we understand the profound problems, the compelling solutions, and the real-world challenges. Now, for the professionals listening, what are the concrete, actionable steps they can implement today to immediately improve communication and data analysis surrounding failures within their own operations? Give us the roadmap, the practical steps.
Okay, here's a clear, step-by-step roadmap to start moving towards greater reliability and a more intelligent operation. First, you need to identify points where failure data is currently lost or delayed. This isn't just a mental exercise. It involves a thorough, hands-on audit of your current reporting processes. Trace the information flow from an operator's initial observation of a fault all the way to when a technician begins a repair. The goal is to pinpoint exact bottlenecks and areas where critical information falls through the cracks. Is it a paper form, an unread email, a verbal handoff that gets forgotten, or a system that's simply too cumbersome to use? You need to find those gaps. Second, begin to install sensors and data recorders on key machines. Don't try to digitize everything at once. That can be overwhelming and costly. Start strategically with your most critical assets, those with the highest downtime, the most frequent failures, or the machines that are consistently problematic. Even a few strategically placed sensors can yield immense value and provide a solid foundation for further expansion, building a strong internal business case for future investment. Third, create a robust system for automatic alerts and failure reports. This is vital for speed and consistency. It ensures information is disseminated instantaneously, consistently, and without human intervention or delays, reaching the right people, whether that's a maintenance manager, a technician on call, or production supervisor immediately. This might be an alert sent to a mobile device, a notification within a CMMS, or an email to a predefined distribution list. Automation here is key to timeliness. Fourth, and this is absolutely crucial for the human element, implement comprehensive training for operators and technicians in both reporting and analyzing failures. This is more than just learning to use a new system. It's about fostering a cultural shift where precise, detailed, and timely reporting is understood as critical to everyone's collective success and the overall efficiency of the plant. Empower them to see their observations as invaluable data points, not just anecdotes, and teach them how their reports contribute to broader insights. Fifth, establish and implement a common platform for data analysis that bridges production and maintenance. This could be leveraging your existing CMMS, a manufacturing execution system, MES, or a specialized digital transformation platform. The objective is to create a single, unified source of truth for all failure-related data, breaking down those departmental silos and fostering true collaboration between teams that traditionally might have operated separately. And finally, sixth, regularly review failure trends and proactively implement preventative actions. This is your crucial continuous improvement loop. It's not enough to collect data, you must act on it. Learn from every incident, adapt your processes, refine your maintenance strategies, and progressively move towards a more predictive and less reactive maintenance model. This isn't a one-and-done project, it's an ongoing journey of optimization, always getting smarter and more efficient.
That's a powerful and incredibly practical roadmap for anyone looking to make a real difference in their operations. Now, to bring this deep dive to a close, if companies rigorously follow these steps and successfully implement data analysis and automated communication for failures, what is the ultimate overarching impact on their operations and financial performance? What's the bottom line for those who embrace this transformation?
The outcomes are consistent, profound, and directly measurable across the board. Companies that excel in this area invariably see a significant, often dramatic decrease in the average time of machine downtime. This is not an abstract concept. It's a measurable improvement directly boosting productivity, throughput, and ultimately sales revenue. Fewer minutes of downtime mean more production, more satisfied customers, and a healthier, more predictable bottom line. It's the fundamental goal of any efficient manufacturing operation.
It sounds like a fundamental shift from constant crisis management, that perpetual firefighting we talked about earlier, to a more stable, predictable, and even proactive environment.
Precisely. These companies also experience fewer recurring malfunctions. By effectively identifying and addressing root causes, by learning from every incident and applying those lessons, they break that costly and frustrating cycle of repeated failures. This leads to more stable, predictable, and inherently more reliable operations. You're not just chasing the same problems over and over again, you're eliminating them, freeing up valuable resources to focus on innovation and improvement rather than endless reactive repairs.
And what are the larger strategic implications for manufacturing professionals when all these improvements take hold? What does this mean for their competitive standing in the market?
All these improvements cumulatively result in higher overall equipment effectiveness, or OEE, and demonstrably lower maintenance costs. These are two of the most critical and closely watched metrics in industrial manufacturing, directly reflecting not just operational efficiency, but also the profitability, agility, and long-term sustainability of the entire enterprise. It's about being lean, agile, and resilient in a rapidly changing market. When your OEE is high and your maintenance costs are controlled, you gain a significant competitive advantage in terms of cost, quality, and delivery speed.
So, in essence, information transparency and its intelligent application aren't just a nice-to-have. It's a strategic imperative for survival and growth.
Absolutely. The transparency and rapid flow of information literally shortens the path from initial failure detection to complete problem resolution. What once took hours, diagnosing, coordinating resources, and executing the fix can now often be reduced to mere minutes. This distinction is critical. It's the difference between a minor, manageable disruption that barely registers and a major, costly production loss that throws everything off schedule and impacts customer trust. It's about proactively building a more resilient, efficient, and ultimately more profitable manufacturing future where every piece of data works for you.
And that brings our deep dive to a close. We've covered a lot today, from the hidden corrosive costs of vague maintenance reports to the transformative power of systematic data collection, advanced analytics, and automated solutions. We even touched upon the cutting-edge capabilities of platforms that leverage IoT and digital twin technology like DBR77 to turn raw data into actionable insights. For you, the industrial professional, the path to minimizing downtime, eliminating recurring failures, and maximizing output is clearer than ever.
I'd just like to add one final thought for everyone listening. In modern manufacturing, amidst increasingly complex machinery and interconnected systems, information is arguably your most powerful asset. By systematizing how we collect, analyze, and communicate about failures, we're not just fixing machines faster. We're fundamentally building more intelligent, more resilient, and ultimately more competitive industrial environments that can adapt and thrive. It's about leveraging every piece of knowledge to your strategic advantage, fostering a culture of continuous improvement and proactive problem solving.
So what stands out to you from today's deep dive? As you reflect on your own operations, consider this. In a world of increasing automation and complex machinery, is your most significant bottleneck still something as fundamental as human communication around failure causes? And what specific steps can you take today to begin transforming that potential weakness into your strongest operational asset? We hope this deep dive has sparked new ideas and provided actionable insights for your journey towards operational excellence. Keep thinking, keep innovating, and keep digging deep into your data.